This first page, okay, this first page is exactly what you had in the other chapter that you memorized and you took a test on and so forth. And now we're going to use it even more. Okay. Right. So in the last chapter, we started integrating problems or integrating functions, but it was all just basic functions. Basic meaning they were not composite functions, right? So it was just sine of x, just ln of x, and so on, right? But we know, functions can get a little bit more complex. So for example, it's not always just sine x. It can also be like sine of 2x, sine of x squared, right? It's not always e to the x. It can be e to the 2x, and so on. When it was time for derivatives, we had to use the chain rule for that. Today, we're going to start the integrals version of that, which is basically the chain rule in reverse, but that's not what we call it. We call it the substitution method, okay? All right, just like for the chain rule for derivatives, remember how if you had a function, so for example, if you had y equals sine of 2x, remember how we had to identify an outer function and an inner function, right? We have to do the same thing in this case, okay? So why don't we just go right into it, okay? All right, steps for U substitution. That's what this is called, U substitution. Okay, so here's what you do. Let me talk a little bit more about when you need U substitution and when you don't. So for example, if I have the integral of x cubed dx, right? I can just integrate this as x to the 4 over 4 plus c. There is no substitution needed. Okay? However, if I have a different function, 3x minus 4 cubed dx, right? This is a different situation. Now that might need U substitution, right? Because I can't just do like to the power of 4 divided by, or to the power of 4 divided by 4. I can't do that anymore, all right? Okay, so here's how to do U substitution. You have to make U the inside function, right? Just like with derivatives, you have to look at the inside function. So for example, we're going to work with this example here. 2 sine 2x. The inside function is 2x. You make that U. You say let U equal 2x. Okay. Next, you find du. This is just the derivative of U. Okay? So if U is 2x, what's the derivative? 2 dx. But the way you write it is, if U is 2x, du is 2 dx. Okay, that's the new notation. Du is 2 dx. Okay, now you have to rearrange the integral so that the new integral now has only u's and all of the former variables disappear. This part is going to be like a puzzle, and it's like black magic. You've got to have faith in the math. It's always going to work. So take a look at this. Here I have sine of 2x, right? That right here too, sine of 2x, that is the u, correct? Okay. And now, what do I have outside of this? I have 2 dx. Do you see that? Yeah. I have 2 dx. Do you guys see that?
Why not the side?
Okay, hang on. Outside of this, I have 2 times dx. What is 2 times dx equal to over here? Du, right? Du. So now, I can write those together. So basically what happens is sine of 2x becomes sine of u. And then the rest of the blue stuff just becomes du, and I've got nothing left. And I just integrate that. Okay? So let's look at it in a different way. What is my function here? My function is sine of 2x. Okay? So can I just write this as sine of 2x and then write the 2 dx together? Why not? I can, right? I can bring the 2 over here. So now what I have is sine of 2x and then 2 dx. So inside of this, 2x is u. So now I have sine of u. And what's 2 dx? I just said that was du, so I just rewrite that as du. Now we integrate. The integral of sine is negative cosine, right here, plus c. But once you integrate the d once you integrate, that goes away. And then you have to put the 2x back, so you get negative cosine 2x plus c. So this is the process. We couldn't have done it in the way that we were doing it before. No, because of the inside functions, you couldn't have done it that way. This is the way you do it. Okay?
You're still adding c.
You're right.
And then you just switch the u back to the
right.
function.
Right. Okay, so let's do an example.
Can you explain why we do that, please?
Because you can't do it any other way. So if you have this, right, how would you integrate that?
Yeah, but I don't.
No, how would you integrate this?
No, I get
okay.
That. I'm just asking from 4 to 5. Like, how's the difference between just
because your initial problem was given an x, you can't leave it as x. You have to now. It was given an x, so your answer has to be back in x. You can't now put a u in there. Okay. All right. Let's do a couple of examples, and then we'll get the hang of it. Okay. Power of 3, right? Okay, so what's the outside function here? It's something to the power of 3. The inside function is x minus 7, and I've told you what the inside function is because I want to focus on the other things for now. So the first thing you do is you say, okay, du, always du, is the derivative of this, which is 1 dx. Okay? Okay, now, so we can basically rewrite that as dx. Okay, now come back to the function. Every single thing in the function should be like substituted so that in the end you don't have any x's left. So look, x minus 7, we said that was u, correct? So that's going to be u cubed. Now what do I have left? What do I have left here? Dx. What's dx? Du. And then we're done. Check. Are there any x's left? No. So now we just integrate this. U to the 4 over 4 plus c. This is what you were doing last chapter. And now just put the original u back. So x minus 7 to the 4 over 4 plus c. Okay? That was a very, very like basic small one. Yeah.
I'm confused what happens to the negative 7. Like why does the x minus 7 cube become cubed?
You took a derivative. So take a derivative of x minus 7. What do you get?
Yeah. Sorry.
What do you get when you take a derivative?
You just get I just get 1.
Right, 1. But now we do dx, just like before we were doing like dy. Yeah. When you took a derivative. So the derivative of x is dx. And then that becomes 0. So du equals dx.
And then why does that become u cubed though?
It doesn't become u cubed because u was x minus 7. So now we have to rewrite this whole thing. So x minus 7 is u cubed.
U.
Okay, yeah. Let's do a couple and you guys will get the hang of it. Yes.
I don't know if it's just this problem, but I'm confused like what the difference is than just like, let's say, taking like x minus 7 to the third.
Let's do some more and you'll see. We have to start with the very basic ones. This is a very, yeah. Okay, so take a look at this one. 2e to the 2x, yes.
Why don't you have to integrate the x minus 7? Like take the...
Because you substituted it. Right, because you can, okay, let's do some more complicated ones and you'll see. Okay, take a look at this one. E to the 2x, right? Instead of e to the x, I now have e to the 2x. So I make this the u, right? So let u equal 2x. Okay? Okay, so if you were to take a derivative here, right? What would be that inside function? The 2x. That's why you're going to make it the 2x. So first you choose the inside function to make it the u. Now we're going to take a derivative, du will be 2 dx. Okay, now let's see what we can do. Okay, so where am I going to put the u, right? It's e to the 2x, so that becomes e to the u. Okay, now hang on. E to the u, right? So from here, I put e to the u. What do I have left over here? I have 2 dx. But what is 2 dx? It's du. So I replace that with du. And now it's all been replaced. If you choose the correct u, and if you do this correctly, there's not going to be any little thing left over. So the derivative of the integral of this will be e to the u plus c. That's from last chapter. And then you have to substitute e to the 2x plus c. Okay, now we're getting into the more complicated things. Okay, so look, this is really where this stuff comes in, okay? So take a look. This is a very complicated function. So of course you go inside of the most complicated part. X squared minus 1 will become the u. So now let's take a derivative. Du equals 2x dx. Always have to have that label dx. So take a derivative of x squared, you get 2x dx. Now, let's go into the function. What did I make the u? It was this. So let's first put in that u. That u will go inside of the root, and it'll be root u. Okay, so this I took care of. What do I have left over? 2x dx. 2x dx. What is that equal to? Du, so I put that in there. So now I'm just going to integrate this. So rewrite it. Add 1. Divide by the new exponent plus c. Dividing by a number means multiplying by the reciprocal. So 2/3 u, which is x squared plus 1, to the 3/2 plus c. You can leave it like that, or you can put it in root form. It really does not matter. Okay? All right, next one. So after a point, I'm going to stop giving you the u, so you have to figure out the u. But right now, again, we've got like the bigger things to deal with. Okay. Sorry, okay. Okay. So this is going to become the u. Okay? So du, you take a derivative. What's the derivative of cosine? Negative sine x dx. Okay, negative sine x dx. Good. So now, okay, take a look. Where did the u come from? It's inside the e, right? So we're going to put that e to the u. Okay, but take a look at what we have left over now. I have sine x dx. Here I have negative sine x dx. So how much is just sine x dx? Negative du, right? So we have to do a little bit of manipulation there. So instead of the sine x dx, I'm going to put in a negative du. But look at how I put in the negative du. Negative can go out there, and the du can go over there. Okay? So take a look. Sine x dx is what I had left over. You have to be able to find that in here somewhere. Sometimes you might have to move something to the other side. So sine x dx is exactly negative du. You bring the negative du, you put it here, and now no more x's. If you did this and you are left with an x, you did it wrong. Either your u is wrong or something somewhere went wrong. The math can never be wrong. The math is bigger than all of us. So if something's wrong, we are the ones that are wrong. Okay? Yeah.
So how would the negative go on the outside of the whole thing if it only technically, like, so you're taking the negative derivative of it?
Right. So you could have also like put it like this.
Right.
But then
Like
it also couldn't come out.
okay, I just wasn't.
Yeah. It's like a coefficient. It's like -1 times something.
Okay.
Okay. Yoni, did you have a question?
That was my question.
Okay. Yeah.
How do you know that the cosine of x is supposed to be
Because it's
like multiple?
inside of a more complex function. Sin x is just sin x, but e to the cosine x, that's a more complex thing, and you go inside of it. Okay, yes.
Wait, how do we get negative e to the
It's e to the u. It's e to the u. Yeah. Okay, what is going on? So let's put the u back, so we get e to the cosine x plus c.
Isn't it negative e?
Right, negative. Okay? Negative e to the cosine x plus c. Okay, here.
answer?
Yep. Okay. Next one. You have something to the power of 4. So that something is your u. Now here we take a derivative. Du is 3 times dx, the derivative of x. Okay. Now, let's go over here. Take a look. I have the integral. What is the u? Always put the u in there first. So it's u to the power of 4. Then, don't freak out. Just ask yourself, what's left over? What's left over in this? Just dx. So go back here, and now you want to isolate the dx here. Whatever that is, you want that exactly isolated here. So dx will be 1/3 du. Right? Isolate the dx.
Could you do over 3 down?
Right. Well, don't, because we have to separate it now. So here, the coefficients always go before. So 1/3 du. Okay?
Oh.
Or you could have done u to the 4 times 1/3 du. This is more like, sort of more efficient later on. So now, 1/3 u to the 5/5 plus c. Okay? So this is, okay, u to the 5 over 15. Combine the fractions plus c. And now you can put the u back. Over 15 plus c. Okay? Okay. Yep.
2 questions. One, anytime there's an e, is it always going to be what it's put to the power to? Because like I just like on d we did the cosine x is what we used in.
You mean the u?
Yeah.
Most probably, yeah.
Okay, and also is u always given to us?
No, only on this page. I'm like,
Example.
yeah, we're like, you know, we're still learning. Yeah.
Why did you get 1/3 du dx?
So when I put in the u, right, it was u to the 4. Then what did I have left over? Dx. So now I have to come back here, and I have whatever that is. I have to isolate it here. Here I have a 3 dx, so I needed to divide by 3. Okay. Next one. Take a look. I have x squared. Then I have this more complex function of a square root and something inside. In that case, how do you pick the u? Go to the complex part and then go inside. So 5 plus 2x cubed. Go to the complex part and then go inside the function. So not the root, just the inside. That's the u. Okay, so what's du gonna be? Good. Okay, 6x squared dx. So now, when you're substituting, always put in the u first. The u goes inside the root. Then what do we have left? X squared dx. So here I need to isolate the x squared dx. So what would that equal to? Right, 1 over 6 du. So how can I put that in here?
1 over 6.
Uh-huh. And then the du here. So this is like a problem from your test, right? So this is going to be 1 over 6 u integral u to the 1/2 du. So this is 1 over 6 u to the 3 over 2 over 3 over 2 1 over 6 times 2/3 times plus c. Man. Plus c. By the way, there was only like 1 or 2 cases on the test where people forgot the plus c, so props. I think that's like a first in like my, however many years of teaching calculus, like, I don't know, 18, whatever. Okay, so what do we get here? So this will be 1 over 9, right? 1 over 9, 2 over 18, which is 1 over 9, and then the u was 5 plus 2x cubed to the 3 over 2 plus c. And that was the last time I gave you the u. From now on, I won't give you the u anymore. And we have to figure out the u ourselves. Okay, yeah.
If we were doing a problem like this on a test, would we leave the answer like that, or would you want us to simplify it?
This is simplified. You don't have to put it in root form. This is as simplified as it'll get.
But I meant, like, do you want us to plug it into a calculator?
You can't because it's like in x's. Okay, now we're going to pick the u's ourselves. Yep. So what would be the u here? Awesome. So what's du? Correct. Okay, integral. U to the 4. What's left? Dx. So how much is dx? 1/2 du. So 1/2 du. And that'll be 1/2 u to the 5 over 5 plus c u to the 5 over 10 plus c. Now we put it back. So it'll be 2x minus 3 to the 5 over 10 plus c. So do you see how if we had just integrated the way we did before, like you can't just take the 2x minus 3, add 1 to the exponent and divide by 5, because then you don't get that extra factor to make it a 10, okay? Okay, this next one, we're gonna rewrite it like this. So what does ln cubed x mean? It's ln of x cubed over x dx. That's what that means. So now when we write it that way, it's ln of x cubed. So now when we write it that way, what do you think the u should be? ln of x. And now this will work out in like the most beautiful way. So take a look. You know what? I'm going to rewrite it in a different way. I'm going to rewrite it yet again. ln of x cubed times 1 over x. Is that the same? Yeah? Okay. So now there is a reason why I did that. So u is ln of x. Okay, what's du? 1 over x dx. Look at that. It's just like, you see that? You have a 1 over x dx just waiting for you over there. So look at what happens here. This is going to be the integral of what? U cubed. And then what do you have left over? 1 over x dx, which is just du, right? So again, there was no way of doing this before. So now this is just u to the 4 over 4 plus c, ln to the 4x over 4 plus c. Okay. Side note. So you have ln to the 4x, right? You have ln to the 4x. You can also write this as ln of x to the 4. That in parentheses, fine. You cannot write it like that, because then it's just ln of x to the 4. Okay? Yep. Okay. Sarah, you had a question first?
Why do you isolate dx on some problems but not?
It depends on what you have left. So after you put in the u, ask yourself, what do I have left over? Here I have all this left over, which I can find it here. But over there, I only had dx left over. So I had to isolate the dx. Okay? Okay, now, having gone through this as a student, okay, by the end of the class, this will start to seem very, very easy. Then you'll go home and then it will just be very, very frustrating. And this is normal because it's your first time ever doing it. You've only done however many we did here. I've done 1,000,000 of them, right? But when I was your age and I had only done 7 of them, it was extremely frustrating, okay? So it's gonna happen, okay? All right. What's gonna be the u here? Okay, and that's usually the hardest part, so good. So u is x squared plus 3, so what's du?
X dx.
2x dx. Okay? So now, integral. Okay, so what do I have here? So the u, okay, so the u is going to go down here, right? So it's 1 over root u, right? Because it's like in the denominator. What do I have left over now? X dx. And what's x dx here? 1/2 du. So here I put 1/2 du. So this is 1/2 u to the negative half du. So let's integrate. What will that be? 1/2 u to the, when you add 1, what do you get? 1/2. Negative 1/2 plus 1 is 1/2. Divide by 1/2. Go slow for these. So this is 1/2 O plus c times 2 times u to the 1/2 plus c. So just u to the 1/2 plus c, which, you know, we can rewrite as x squared plus 3 in a root plus c. You can also rewrite it as x squared plus 3 to the 1/2. That works as well. Okay. Oh, what about this next one? What would you, nope, can't be 2 u's. Look for the more complicated part and go inside. X cubed plus x, this one. Just the inside, not with the square, just the inside. Isn't that cool? It's like, yep. So look, u is x cubed plus x, right? So what's du?
Is 3x squared
Plus 1 dx, right? It's the first parenthesis. So this inner, yup, I'm telling you. So what do we have left over? This times this. Oh my God, that's just du. I'm telling you, you have to trust in the math. If you do it correctly, it's got to work out because math said so, right? And that's all we need. Okay, so u cubed over 3 plus c x cubed plus x cubed over 3 plus c. Oh my gosh. Okay. Yep.
So do we just like look at it and like just know which one is the more complex one?
Yeah, right? Because like if it's like just a parenthesis versus
More
something
complex to
squared.
solve?
Yeah, it has more like layers, you know? Yep.
Will we ever get a problem that's like both of these parentheses have an exponent
No,
I just want to be.
I don't think, no, because, no.
Okay.
I don't think so.
Did you not substitute back into the DU?
Huh? Yeah. I did, yes. I did. Du. So when I put this in here, u squared, then what's left over? This times this.
Yeah.
All of this is du.
Okay.
So all of that became du.
Okay.
And then I integrated it, I got that. Okay. There was actually a problem with trig identities, which I've taken out. So, okay? All right. So,
Are we saving that for later? Or just now?
no, we're not going to do it.
Okay.
If we had one more day before Shabbaton, we would have done it. Okay.
Oh no.
Now, what about the definite integrals? What if you've got the u's? I'm sorry, the bounds, right? A to B. Okay, what do you do then? You basically have to do a little bit more substitution, okay? So the formulas are always more tricky. It's easier if we just do them. Okay.
Let's dive in.
Huh? What did you say? It sounded like.
No, I said you do like what we just did, and then you just add the bounds, and you just incorporate them, right?
Yes.
Chill out.
And no, but yes. Okay, so basically what you want to do is you want to change these as well.
What?
Change them. So A becomes U of A, B becomes U of B. But I will tell you. Okay, so here we go. What do you think the U should be here? Fabulous. Okay, that's right. So du is 2x dx. Okay, now let's do this. Okay, the u will go underneath, yes? What do I have left over? X dx. So it'll have to be a half in front, du. Okay, so far it's everything like what we did before. But now we have bounds. So here's what you do. You already have the u, correct? Okay. You're going to put each of these numbers into the u and get new numbers. So the top number is a 1, correct? U of 1 is 1 squared minus 4. So just put the 1 into the x here, and you get -3. That -3 takes the place of the 1. The other number is a 0. U of 0 is -4. That takes the place of this. So now, this is 1/2. What's the integral of 1 over u?
Oh, ln
Yeah, ln of u. From -4 to -3. But it's ln of like u in absolute values, remember? So ln of u like this, that matters here. From -4 to -3. So this is half of ln of absolute value -3 minus ln of absolute value -4. Half ln of 3 minus ln of 4. Okay?
That's it.
I feel like we're doing
That's all. That's the end.
So now, remember properties of logarithms. I was just teaching this to trig today. You learned it in Algebra 2 and
Funny story actually.
half. This is the same as ln of 3 over 4. Why?
Yeah.
Because you know.
Oh, the
Because if you have,
subtraction thing.
right.
Oh my gosh, I was so.
The subtraction thing. Okay.
Can I just leave it as how it was?
No.
Wait. No, don't leave it at
Okay. One more and you can get your test back. Shh.
That was so quick.
Good job.
Good job.
Okay. Shh. Okay, so this is the one case where you kind of have to do a little bit of a trial and error. So what would you say the u should be? Okay,
You're wrong.
That's why you'd be wrong.
so
No.
technically, if you went by the more complex thing, it would have been secant x, right? The stuff inside. But what's the derivative of secant?
Tangent.
No, it's
Secant x
secant x
tangent.
tangent x, which doesn't fit here.
Obviously.
However, if you pick u to be tangent x,
Then it's secant squared.
then it's secant squared x.
But like, why does that matter?
Because you wouldn't be able to substitute afterwards.
So you can choose.
No, you can't choose. There's only one way. There's one way. So if you happen to if you happen to pick wrong, right? If you picked the wrong thing and you did du blah blah blah, you wouldn't be able to substitute as like, you know, seamlessly. Like nothing, like things will not go away.
Well, it's also like we don't even know.
Okay, let's finish this and then we'll take some more example. I'll take questions. So this is going to be the integral of u, and then this is all just du. Okay? So now, the bounds. U of pi over 3 is tangent of pi over 3, which is root 3. So that goes here. Okay. U of 0 is tangent of 0, which is 0. That goes here. Let's integrate. U squared over 2 from 0 to root 3. Okay, so now we have root 3 squared over 2 minus 0 squared over 2 is how much? 3 over 2. Okay? Yep.